Chapter 3 is the introduction to optimization models. In other words, linear programming. So I'm going to start with an example, and then we'll go through the example using what is called graphical method, and then I'll finish up with discussion of linear programming concepts. So here is a company that makes two different models of computers called Basic and XP. Now when they make and sell these two products, they make profit of $80 a unit on Basic and $129 per unit of XP. These numbers need to be calculated. If you look at the textbook, it has information on how to come up with this $80 and $129, and we'll look at that when we use Excel to solve this problem. For right now, let's take it as given. So the profit is $80 for Basic per unit and $129 for XP. Now there are some sales forecasts, and we can sell up to 600 units of Basics and up to 1200 units of XP, and that's the maximum that we can sell. We will not be able to sell more than that. So that is a limit, 600 and 1200. And also, to make these computers, there are two different types of labor is required. One is assembly labor and the other is testing labor. The Basic requires 5 hours of assembly labor. XP model requires 6 hours. And for testing, Basic model requires 1 hour of testing. XP requires 2 hours of testing. And the labor hours available for assembly and testing are given by these. There are 10,000 hours of labor available for assembly and only 3,000 is available for testing. Now the company wants to know how many of each of these two models it should produce, meaning assemble and test, so that the net profit is maximized. But of course it cannot use more than the labor hours available for assembly and testing, and it cannot produce more than what it can sell, the maximum sales possible. So within those constraints, we want to maximize the net profit. So the objective is to use linear programming to find the best mix of the computer models to maximize profit, stay within the company's labor availability, and don't produce more than what can be sold. Now this problem can be set up as a graphical problem because there are only two quantities that we need to determine: how many units of Basic model we should produce and how many units of XP we need to produce. So we're going to go through the graphical model first, and the idea here is to understand the concepts. We're not going to use graphical method for solving any of the problems. It's only for understanding purposes. We'll be using Excel solver to actually set up and solve problems. So in graphical method, of course, you have an x-axis and a y-axis, and we assign one of the two models to x-axis and the other to y-axis. So for example, like this, x sub 1 would represent the number of Basic models, and we assign x sub 1 to x-axis, and we assign x sub 2 to y-axis, and that will represent the number of XP computer models. And we now set up a scale for x-axis and y-axis and set up the net profit. The net profit now is 80 x sub 1 plus 129 x sub 2, and the coefficients for x sub 1 and x sub 2 give us the slope of this net profit line. So here are the x-axis and the y-axis are scaled properly, and we draw the line for some given profit. So if x sub 1 is set to 1290 and x sub 2 is set to 0, you get a net profit of 103,200, and that represents this point. And similarly, we can set x sub 1 to 0 and set x sub 2 to 800, and that will also give you the same profit, 103,200, that represents this point. If we connect these 2 points, that gives us the net profit as a straight line for a profit of 103,200. So any point on this line will give you the same net profit of 103,200. The values of x sub 1 and x sub 2 will be different. Okay, so as you come down this line, you will get different combinations of values for x sub 1 and x sub 2. They all will give you the same net profit. Since the profit along this line for all the different points, for all the different combination of values for x sub 1 and x sub 2 will be same as 103,200, this is called iso profit line. Same iso profit meaning the same profit. And if you want to increase the profit, keeping the slope the same, so for same $80 per unit for x sub 1, the base model, $129 per unit of XP model, then we can move this profit line up like this, and as it goes up and up, the profit will change, but that for any given level along that line, the same profit will be achieved for different combinations of x sub 1 and x sub 2. As you go up, the profit will change, it will increase from 103 to 130, 140, but along the line for various different combination of values of x sub 1 and x sub 2, the profit will remain the same. But of course this profit line cannot be pushed without limit. There are some constraints that we have to take into account.